So I'm going to have you go ahead and try 3 and 4 on your own. I'm going to do 5, and then I will post the answers to 3 and 4 so you can view those in the next video lesson or in that part of Canvas, in that part of the module. So let's just look at h of x equals 6x minus 5 divided by 3x minus 4. And again, for the vertical asymptote, that is when our denominator cannot be 0. Well, it's when the denominator is 0, we have the asymptote. So we have 3x minus 4 equals 0. And so if I add 4, I get 3x equals 4. So x equals 4/3. And so that means that my domain is going to be all real numbers except x equals 4/3. My vertical intercept, I'm going to wait and have Desmos give us that information. For my horizontal asymptote, I know that that is going to be the constant rate of change of the numerator. In this case, it's 6. So y equals 6 over the constant rate of change of the denominator, which is 3. And that means my range is all real numbers except y equals, and here we can simplify this if we want to. We can simplify it now if we want as well, simply because we've already gone through the exploratory piece of this. So we can say that y equals 2. You can leave it as 6/3 if you want to. And again, the horizontal intercept will let Desmos do that. But we need to graph our asymptote. So we need 4/3 and we need 2. And so I'll start off by labeling my axes. So this is the x-axis, this is the h of x-axis. I need, well, actually, let's go to Desmos and figure out where our vertical and horizontal intercepts are, just in case we need to have, so we can figure out how to scale this, see if it's greater or less than these values that we already found. So going over to Desmos, I'm going to put in h of x, and again, starting with a division key or equals, and then the divide key or the slash. We can easily put in our 6x minus 5 over 3x minus 4. And we can see, so we can also put in x equals 4/3. And we can put in y equals 2. And if we want to change those and see that they are actually dashed and not there, so there's each one of those. You don't have to do that, but that just helps us visualize a little bit more of exactly what we're going to put into our graph. We see that we have a horizontal asymptote at 0.833 or comma 0, and then 0 comma 1.25. So back to our note sheet, we know that our vertical vertical intercept is 0 comma, make that a better 0 comma 1.25, and our horizontal intercept is going to be 0.83, repeating, comma, and the output value is 0 here. Okay, so now we know how we can kind of scale this, so we don't have to go too far. We really just need to go maybe count by 0.5s. Remember, scaling is very important. So there's 2, and there's 3, and we can do the same thing here. We don't really need too much over here, so here is -2. And then same thing, let's go ahead and also count by 0.5s. And so there is 1, 1.5, so there's 2, and then there's 3, and we can do the same thing along vertical axes. So there's 1, there's 2, there's negative 2.5. Okay, and so now we always need to draw in our asymptotes first because graph pieces are approaching those asymptotes. So we have x equals 4/3, so that's 1 1/3. So x equals 1 1/3. And we need to label these so we know exactly where they're at. So x equals 4/3. And then our horizontal asymptote is y equals 2. So there's our horizontal asymptote. We get y equals 2. And then we do know that the horizontal intercept, so we have a point at 0.83 comma 0. So that's approximately here. And then our vertical intercept was 0 and 1.25. So there's 1. So about in the middle. And now all we're doing is connecting our points. Remember, one-sided arrows because we're approaching. And then this kind of mirrors the other side. I don't need any specific points necessarily, but just a general graph of those points.